This video is intended for calculus students who are interested in refreshing some of their advanced factoring skills. Problems like this often come up in the calculus sequence. So let's begin by reviewing some factoring. This expression has two terms, so we want to begin by determining the greatest common factor, the GCF. And it actually is probably easier to start with a simpler problem. So let's say I wanted you to factor 2x cubed plus 8x squared, which also has two terms. We would start by determining the GCF. So the greatest common factor between 2 and 8 would be 2. And then between the x cubed and the x squared, we would factor out a greatest common factor of x squared. Notice we're factoring the piece that had the smaller exponent. And when we say we're actually factoring out 2x squared, we're really dividing each of these terms by 2x squared. So when you first learn to factor, you might actually show this division to determine what remains. 2x cubed divided by 2x squared simplifies to leave us with just an x, and positive 8x squared divided by 2x squared leaves us with a positive 4. So this is factored, noticing that it is a multiplication problem. So our factored form actually is a product, and that's what it means to factor, to rewrite the original expression as a product. So let's use this exact same strategy on the current problem. Starting with the 8 and the 10, our greatest common factor is 2. Next we have x to the negative 1/3 and x to the positive 2/3. Negative 1/3 is the smaller exponent, so we'll include x to the negative 1/3 in my greatest common factor. And lastly, 2x plus 1 cubed and 2x plus 1 squared. Our GCF there is 2x plus 1 squared. Again, looking at the smaller exponent. So just for the purpose of explanation, I'm actually going to show this division. And of course, many of you have factored for a long time and no longer show this division step, but sometimes this is very helpful when you're trying to wrap your mind around the more advanced factoring problems, ones that have negative exponents or fractional exponents. So I am going to rewrite this. Now I have my greatest common factor, 2x to the negative 1/3 times the quantity, 2x plus 1 squared. And we will do our division to continue factoring this. So 2 divides into 8 4 times. X to the negative 1/3 divided by x to the negative 1/3 is 1. And then we have 2x plus 1 cubed divided by 2x plus 1 squared, which would leave us with the quantity 2x plus 1, technically to the first power, but we don't need to write that exponent. Just as a reminder, how we obtained that was actually by subtracting these exponents. So 3 minus 2 left us with an exponent of a 1. Plus 2 divides into 10 5 times. Again, here we have x to the 2/3 divided by x to the negative 1/3. So top exponent is 2/3 minus bottom exponent is negative 1/3. That'll actually give us 2/3 plus 1/3, which is 3/3, which leaves us with an exponent of a 1. So that simplifies actually to just x to the first power, but once again, we're not going to write that exponent of a 1. And then 2x plus 1 squared divided by 2x plus 1 squared. Those divide out and equal 1. My bracket didn't need to be quite so far over. So this would be my factored form, which we can actually simplify what's in this bracket by distributing. So this will be 8x plus 4 plus 5x. So my simplified factored form will be 2x to the negative 1/3 times the quantity, 2x plus 1 squared, times the quantity, once we combine like terms, 13x plus 4. So final answers down here, and this is my factored form.